That's fascinating. But before we get to can I compute the next thought, this makes me think of things like clinical trials. I mean, if you can simulate a cell, I would imagine you could set up a whole bunch of systems of cells to basically do a clinical trial that doesn't involve patients and all of the uncertainties they often bring. Like designing a clinical trial to get at different demographics reliably is really hard. Like, do you see this being useful in that way?
Absolutely. And Susan, I think it comes back to the notion of Sidney Brenner, which is that, you know, in physics, and I love physics as a hobby and as a subject, you're only as good as your predictions. So in physics, you have a theory, the theory makes predictions, you test the predictions. For some reason, in the biological sciences, nobody's interested in predict. For example, if I mutate the protein, can you tell me, will it bind 10 times worse or 10 times better? What will happen to the cell
Right.
quantitatively? Like, will it change its replication rate? And in biology, we're not spending enough time building theories that are predictive. And the
Interesting.
minute you
Yeah.
do that, and going back to clinical trials, what you're saying is you can predict the outcome of something. You can actually have an understanding that is so predictive. You can begin to do things that were never imaginable before because you have that ability to simulate the
Yeah.
system and predict its evolution.
Yeah.
And I mean, that will provide immense power for medicine. We don't design drugs. We do trial and error. People do
Yes.
vaccines. It's
Right.
actually shocking, by the way, if you're a physicist and you actually accept that in today's world in 2023 we're still just doing trial and error
Yeah.
and aren't able to actually, like, predict the drugs that are going to cure all the diseases.